So in our last video, we looked at the standard derivative for the power rule. And in this video, we're going to look at these four types of function when we have y equals sin ax, and a is going to represent a numerical value. When we have y equals cos ax, again, a in all of these will represent a numerical value. When we have y equals our exponential function there, and our logarithmic function. So let's get into the examples so we can see how to treat each of these cases. Now for our first scenario here where we have y equals sin ax, the standard derivative of that is dy dx, and in the last video we discussed what the derivative means. So for this case, dy dx is going to be equal to a cos ax. Now let's look at an example where we use this format. So in this example, say we have y equals 3 sin 4x. So if we were to differentiate this, then it would be dy dx is equal to, and what we're going to do is multiply the 4 and the 3. So this would be 3 times 4, and we just replace the sin 4x with cos 4x. So our final answer here will just simply be 12 cos 4x. So if we were to just quickly examine what happens here, so we just simply change the sin to a cos, and whatever value we have here in the function, where we have 4 in this case representing a and 3 as the coefficient, those two will be multiplied right there, and that just leaves us with our final answer, 12 cos 4x. So that's the first case, and that's what you will do in all of these. Now let's look at the second case where we have cos ax as our function. So for y equals cos ax, the differential equation for that is dy dx is going to be equal to, in this case we have negative here, so negative a sin ax. And let's look at this with an example now, because that always tends to cement everything. So say we have y, so y equals, let's use 2 cos 3x, and we're going to find the differential equation for this. So if we follow our structure there, then dy dx, so negative 2 times 3, and we'll have sin 3x. And then now when we finalize this here, dy dx is going to be equal to negative 6 sin 3x, and that's going to be our final answer here. So if we were to just quickly analyze what happens here, so in this case our cos is going to be changed to a sin, and the coefficient here, which is 2, is going to be multiplied by our 3 right there, because that negative symbol here was already in the formula, so it's embedded. So what we have then is negative 2 times 3, which gives us that negative 6, and then sin 3x. So that's our final answer. So let's look at the next case then. So for this case, it's when we have y equals ax, and this is perhaps one of the simplest one. So for this, we will have dy dx is equal to, that's a e to the power of ax, and in this case is our exponential equation. That's what we get. So for this example, I will use y equals 3e to the power of 5x. So let's get into the differentiation now. So for this one, we'll have dy dx is equal to, and we're going to follow our same structure there. So what we'll end up with is 3 multiplied by 5, and then we have e to the power of 5x. So final answer here is 15e to the power of 5x. And let's examine what happens here. So what's happening here is the coefficient there of the x in our power is multiplied by that 3 there that we have in our coefficient for this exponential term. That exponential term right there. Now what's happening then is after we do our 3 times 5, we just literally replace whatever this term here was in our exponential term. So that leaves us with 3 times 5, 15, and then times by e to the power of 5x as we had before. So say we have this format, y equals ln, so that's a natural log, ax, and that's equal to dy dx equals 1 over x. So as you can imagine, this one is going to be straightforward. So let's look at an example with this. So say we have here y is equal to, I'm just going to start with a relatively simple one. So that's the function that we have here to differentiate. Now this bit here just by itself is just simply 1 over x. So what that will look like when we differentiate it is dy dx is equal to 6. So that's that coefficient multiplied by 1 over x, like that. And if we were to simplify it, then it just goes to 6 over x. And that's simply because if we didn't have that 6 as a coefficient, then when we differentiate this here, doesn't matter what the coefficient right here is, it will still turn out to be just 1 over x. So that's why this is our final answer. So if you got some value from this video, please like the video, subscribe to the channel, and in our next video we're going to look at our product rule and our quotient rule. So I'll see you in the next video.